Hello everyone, welcome back to Let's Unbound. In this AP Precalculus series, we are unlocking a new episode. This is the 12th episode. We are in 1.12 transformation of functions. It's a very important topic and where must know concepts are in this video. So do watch the video from the beginning till the end. Be ready with pen and paper, take the notes and try problems with me. Here we go. So what is transformations basically? It modifies a graph of a function without altering its fundamental nature. Linear means even after transformation, it will be linear. Cubic, still be a cubic, but the fundamental nature will not be changed, but it affects position, shape, and orientation. Right? So let's see transformations one by one. First, we have many kind of transformations: vertical, horizontal shift. First is shifting, we call it translation, then reflection, over a line or over an axis. So we will be doing over an axis, and stretching and compressing. So the graph will become taller, narrower, wider, flatter. These will come under stretching and compressing. See? So now let's go with translations. Translation will shift the graph, so exact shape will be preserved. The parabola will still look like a parabola, exactly how it is, how wide it is, how tall it is, everything is same, just location will be changed. Two kind of translation: vertical, it affects the output values. Yes, of course, change in place, the output values will be altered. And horizontal translation, it will affect the input x values. See, this is the blue is the original function. And here in this red is the original, it got transformed. I shifted right, but exactly the width of the graph, everything is same. Only the location had changed. So here inputs will change. Here it attained 2. For example, it attains 4 when x is negative 2 and positive 2. Here it attains the value of 2 somewhere not at 0 or not at negative 2, but at some positive values, right? So input values will be changed and output values will be remain the same. Now, vertical shift, the graph is shifted upwards, but rest everything is same. So output value, so x is still 0, but here 0, 0, here 0, 5. Output value had got a change here, right? Now, translations algebraically. Algebraically, you have original function f of x. Now, new translated functions, vertical translation means k will be, any value, a k will be added outside the function. Okay, so should I add inside? No, this is called inside addition. We will, and this is outside. So outside should be added for a vertical. If that added is positive, the graph will be shifted up. If the added is negative, it will be shifted down modulus k units. Right? So if I am minus 5, if I put, it will go down 5 units. Then horizontal means original function will undergo right or left thing. So here something should be added inside. So I'm giving h for horizontal. When h greater than 0, here it's important. When h greater than 0, it's not right, it's left. Okay, so f of x plus 2 means we are not moving right side, we are moving left. So whenever we do horizontal, it will be reverse, right? Positive means right. That is the one thing we learned. But this time, horizontal translation, whatever horizontal will be in reverse nature. And less than 0 means I will move right. So f of x minus 2 means I will move 2 units to the right of the graph. Okay, so this is one important. Now, reflections means we are reflecting a graph over x-axis and y-axis. This will also will not change the shape, like it will not be enlarged or like that. So this will not change the shape, but only its orientation, the way it's progressing, that side will be affected. For example, vertical reflection of the parabola over x-axis means it will be flipped over x-axis. So when you flip this, it will be just looking down, but it's still a parabola, same with everything, but the orientation, the direction they are progressing is changed. Horizontal reflection, this red dotted graph is original. Y-axis reflection. So each point should be get reflected. So this point will get reflected here, this point will reflected here, and origin reflection will be reflected on the same. Like that, we got this. So y-axis reflection is horizontal reflection. And here also, y-axis means we often think vertical, but it's not a reflection. Y-axis is horizontal reflection. And x-axis is vertical reflection. The graph flipped vertically. Here the graph flipped horizontally in that case. right? Now, algebraically, if you multiply a negative one with before your f of x, so throughout your f of x, okay, that is x-axis reflection. If you multiply negative for every x values, right? Not for the whole function. For example, if you got x square plus 2x minus 3 means, if I multiply for everything minus x square minus 2x plus 3, the entire function got multiplied by negative. This is a vertical reflection. Horizontal means only wherever x comes, you change it to negative x. So x square plus 2x minus 3 will be minus x square plus 2 times minus x minus 3 in that case. Okay, so this will be completely different, not changing sign of everything. It depends on the function. So only x values you multiply with negative 1. Here full function you will multiply by negative 1. And points will become xy will go x minus y. This will go minus x and y. Right? Now, stretch and compression. Stretch and compression means, let's do vertical and also horizontal stretch and compression there. So vertical stretch and compression transform. So this will affect the shape. Okay. Like not like parabola will become a cubic graph, but it will get pulled, it will get shrinked, compressed like that. So this vertical stretch or compression will tell how tall or flat a graph appears. So for this, we will be using multiplication, multiplying by number with outside a function will result in vertical stretch or a compression. So when it is stretch, when your a is greater than 1, it's a stretch. 1.13,000. So this will stretch the graph and it will become taller. So original parabola is like this. If you multiply, like this is x square means, if you put 5x square, it will become stretched and it will be pulled like away from y-axis. Actually, the origin will not change. Okay. So it will just become taller. Okay. And it will be towards, it will shrink towards y-axis. And what if it's between 0 and 1? We are not using negative scale factors. Okay. So 0, if your a is between 0 and 1, the graph compresses, it becomes shorter. For example, this will become like this. Okay, same origin will be same, but it become more wider. Like it will become flat, this will become taller. So the x value stay same here, but y value scale a. For example, if you put 2, you got 4 means. Now you put the same 2, but you will get something like 10. So right, so 2, 4 will be here original, 2, 10 will be here. So it will become taller. Okay. So this is vertical stretch and compression. And graphically, this will be like this. If your modulus A, we are using modulus, sometimes negative 2x square will also come. We'll see about this negative. This negative, right, it's reflection. So negative 2 means 2 things, reflection and then a stretch, vertical stretch. Okay. So we are always checking the positive modulus value. So if it's greater than 1, it will be pulled away from x-axis. This is closer, but the blue one is getting away. Or you can say it's moving towards y-axis also. If it's between, it's coming closer and closer to x-axis. It's getting flatter. Now, this is how we should multiply entirely with our scale factor for a vertical stretch throughout the function. Horizontal stretch or compression, it's again multiplying, but inside. For your x value, f of x is y value, outside multiplication. X is in input value, we are just multiplying this. So that's the difference. If your b is 0 to 1, then it is a stretch. Okay, there it's b greater than 1 stretch. Here b is 0 to 1 stretch. I said, right, horizontal always behave in a reverse way. Right. So what happened? It will stretch horizontally means it will become wider. This parabola will become like this. And b greater than 1 means compresses the graph. It will become more narrower. The y value will be same. X value will be scaled by not b, it's 1 by b. Reverse everything, right? So 1 by b, this should be kept in mind. Okay, so if I f of 5x means your scale factor will be, y will be same, x will be some x by 5, not 5x. Okay, so that's it. This is how it would be if b greater than 1, the red is original and it becoming more squeezed towards y-axis, right? Compression. And here it becomes more and more flatter. So here I give 3, here I give 1 by 3, just reciprocal of it. See the change, correct? Now, fully transformed algebraic version of a function. Original function is something x square or something. If you applied all transformations, like this A will represent vertical stretch, or if it's a negative reflection also will be there. This D will represent vertical shift. B will represent horizontal stretch or compression. C will represent horizontal shift. So how should I solve this? You always have to work inside to outside. Okay, when we are working under the transformed version, from inside, you can't start, don't start from I will multiply, I will reflect vertically first, then I will horizontal. No, inside stuff you have to complete, then you have to do the vertical things. This is the key. And now question 1. Given the table values of f, let g of x be f of x plus 1 minus 4, find g of 2. So g of 2 is, if you just put wherever x comes, you replace it with 2. So f of 3 minus 4. What is f of 3 from the table? 15 minus 4, which is 11. So g of 2 is 11. Very simple, basic level question. Right? Now, question number 2. Let f of x is equal to root x. Write the equation of a function that reflected across x-axis, y-axis, compresses it vertically by a factor of half, shift its 2 units to the right and 3 units to the down. First, let me tell you, what if it's just f of x? Reflects across y-axis means inside minus. Okay. Across y-axis means horizontal reflection. So inside, actually, it's f of minus x. It will change. Okay. So f of minus x. Then compresses vertically. Vertically means outside, and outside means whatever the factor you just use as it is of f of negative x. And shift 2 units to the right. Here comes an important thing. Okay. Right or left shift means I should do inside. So negative, this x only, don't take, and right means minus 2. Okay, so negative x minus 2. Then 3 units down means outside negative 3. Okay, this is how it is for general function. Now let's do for root function, square root of negative x. Then I'm multiplying 1 by 2, of course. Then if you put minus 2, it will be wrong. Only for x we are doing minus 2, not for minus x. So use a parenthesis. So this says right shift 2 units. Okay. Then minus 3 outside, don't put inside the root. And if you want, you can simplify this. Half square root, 2 will become positive, x will become negative, and minus 3 outside. This is the correct equation of the transformed version. Right. And moving to question 3. Okay. So g of x is negative f of x minus 2 plus 1. F of x is shown in the graph. We have to graph g of x. So apply all the transformation described in this equation. Okay. And then state the domain of g. Once you got g graph, then these are simple. Domain, range. From the graph, we know how to find g of 0, zeros of the graph g, y-intercept of g. Everything is easy. So let's go. Okay, so remember this thing. You can't use, like, I will use reflect, then shift, then shift. No, don't do that. Inside. Inside, only one operation had been done. So let's do f of x minus 2 first. Okay, so first shift right 2 units. Okay, it's right or left? Right. X minus 2 means right. Right 2 units. Then you should not do plus 1. Right? Then negative f of x. So negative f of x minus 2 means reflect over what axis? X axis. Outside means x axis reflection. Actually, it's vertical. Vertical means don't take x axis. Okay, I'm reminding you. Then plus 1 minus f of x minus 2 plus 1 means this should be shifted up 1 unit. Okay. So here, let me do it one by one. First, x minus 2 means, and key points alone you can do. So this end point, this, these are key points. Okay, these alone we can do. Okay, where it is here. So 2 units means this will come here, like from here. Everything is spaced 1 units here. So 2, right. This point will move here, 2 units. Okay, then this is one important point, like the key points alone you can do. And this is 1, 2. And this is 1, 2. Okay, now let me graph this. You have to go in order. Don't go like this, this, this. We know the order, right? So It's a semicircle, then a little straight line, the green line, and this. Okay, so it should be like this. Okay, this is done. Now let's do f of negative x minus 2. Sorry, negative f of x minus 2. So reflecting across x-axis. How will you reflect? Okay, it is at positive 2. Same x value, you point negative 2. This is at positive 5. Same x value, you come to negative 5. So this value now. This is at positive 2. Same, you come to negative 2. So just y value will get negative. That's why it's vertical reflection. And this point is 1. Same, you come to negative 1. And this is 2.5 actually. Be careful. So same, you have to come 2 and negative 2.5. So a semicircle, a line, again a line. Okay, the red got reflected. So done. Next is, let me take blue color for this. Shift 1 units. So very simple. This will go here, this will go here, this will go here, this will go here. 1 units we are shifting up. This will go 1.5. Then you sketch it. 8. Smooth curve, straight line, and a straight line. Okay. So the blue is the final version of the graph. Okay, you can do it step by step. Let me tell you how to do it very quick to save the time. Okay, we are not going to do everything like this. Every transformation you can apply all transformation together. Let me take this color. So this is 2 units right, then reflect it over, means it will come here. Then you shift 1 units up. That's it. You will come back to the same point. Then this point 2, then reflect 5 means negative 5 and go 1 up. You will be here. Same graph. So we can do same for other points too. We will get into the same coordinates and the same graph. In one go, we can do that. Right? So this is the required g of x. Right? So graphing part is done. Now. Okay. Yeah. State domain of g and state the range of g. Domain means how will you do? From your graph's leftmost endpoint, this is leftmost, you go to the x-axis and yeah, and the rightmost endpoint you go. If it's any break, you should notice, but this is what I got. So what it is, this negative 4 continuously till 6. So B is closed interval negative 4 comma 6. Right? Next one, C. C is finding range. Range with same thing. Go to lowest point of the graph. We are doing for G, not for this one. So this is the lowest I can see. Correct. This is the lowest. And go to y-axis. And it says minus 4. And what is the maximum on this G? This one. It's 0. So I draw the line. It's minus 4 to 0. Both are included. So range is negative 4 to 0. That's simple. Now, D. Find G of 0. G of 0 means when x is 0. That is x-intercept. Right? When y-intercept. Find G of 0. Where your graph G of 0 in the sense where your x is 0. So the graph crosses x-axis, it's somewhere over here. Okay, so this point, actually it's not perfect number, whole number, correct? So it's somewhere this negative 4, it's negative 3.8 or it can be negative 3.9. So that is G of 0, which is nothing but y-intercept. Correct. So D and D are the same thing. Okay. So for G of 0 is negative 3.8 or 3.9 approximately. Y-intercept is also like you can tell negative 3.8 0 comma negative 3.8. Approximately you can tell. Find the zeros of G means where your graph crosses x-axis, this point. And it is 1, 2, 3. So E is x is equal to 3 is the 0, only 0 here. For G. That's it. So this is a crisp overview and 3-tier problem solving on transformation of functions. Right. So we are moving to bonus question. A function is given as a reciprocal function. Write the equation that reflects, shift, and add 2 units up. And also you have to describe the transformation step and sketch the expected behavior. Okay. So in comment section, you can just give me the equation alone. Okay. And yeah, you can even describe it in your own words. So sketching, you do it on your own and also use Desmos to cross-check your answer. Right. So if you have any suggestions, feedback, questions, you can comment in the comment section. So that's it. Here is the final thing. Thank you for joining and learning today. We will be meeting in next video very soon. Until then, keep learning, keep practicing, stay curious.